Hello. In this lesson, we're going to talk about making stairs. Let's start with a sketch of with 2 units and a height of 4 units. We're going to say that our stairs will start at the south side of my sketch and will go up in the north direction. Okay? Well, first we have to define our variables. The two main variables of a stair are the rise and the run. Then the riser, there is the height of your step, and the thread. Those are the main variables for our stair. Our run will be the same that the dimension and the east or west dimension of my my sketch. So I will make a binding of my sketch that I will assign to the variable run the length of the largest segment label, I say west. Now I have a variable that is taking the run of my stairs. The rise of my stairs will be an input variable. The rise, I will say my stair will rise 3 units, and then I have to calculate my riser and my thread. And this is the way to do that. There is a standard for stairs that the relation between the riser and the thread of a stair must be approximately 0.18 for the riser and 0.28 for the thread. This is the standard stair. We are going to try to keep the riser and adjust always the stair, the thread. So we're going to calculate here how many risers of 0.18 units fit into a total rise of 3 units. For that, I will add another variable, number of steps, the number of steps. I'm going to put it here, and then make the calculation that will be math.ceil of 3 divided by 0.18 units, and that will be my number of steps in my stair. Now my riser, the real height of my riser will be 3. Sorry, not 3 here. This must be rise. All right. This will be rise, and my riser will be rise divided by n steps. This will be my real riser. And the same way, my thread will be run divided by n steps. I have all the calculations for my stairs. Now I'm going to start building it. First of all, we're going to define a profile for my stair. That will be step. This is my profile. My profile will have, it doesn't matter how much it have, because I'm going to use variables for that. Here my length will be the riser, and here my length will be thread, and then I'm going to add a repetition of n steps. Now I only have to make an extrusion, and the south border of my sketch, we're going to use my profile step, and let's see the result. The result is that if you see here, you have your 3 units in the rise, your 4 units in the run, and your steps will be 0.18 by 0.24. You can choose between seal or floor your amount of steps. That will be one more or one less step for your stair. If you select here, instead of seal, you select floor, you will have one less stair, one less step, and your steps will be bigger, 0.19 by 0.25. It's up to you how do you want your stair. The interesting part of this is that these stairs can adapt to any kind of dimensions, and will keep your risers in architectonical correct dimensions. Now I reset the the sketch here, and as you see before, this is one kind of stairs. But what if you want to make a stairs with a slab, not feel down the stairs like this, but a stairs with a slab? Let's see how can we do that. First of all, we have to calculate the angle of elevation of the stairs. That will be another variable, that will be angle, and my angle will have a formula that will be math.arctangent of the rise divided by the run. Okay, that is an angle but in radians. Now we have to convert it to degrees, and this is the way to do that. We multiply by 180 divided by math.pi. Now I have the angle of the stairs. Let's run it. The angle of that one. Let's see again. All right. The angle, I have an error there. We have a typo on our formula. It's math.pi. Now let's see my angle. All right, this is my angle, 36.86 degrees of elevation. Now we are going to calculate the space that you have to, for that you have to first cut parallel to the south here one distance that have another formula. First, we have to define the thickness of the slab of the stair. Let's make another variable, slab thickness. And I'm going to fix my slab thickness as 0.2 units. That is a concrete slab normal. And then I'm going to calculate that distance that I will make in another variable as t. And t will be slab t divided by the tangent of the angle, but this angle now is in degrees. I have to convert it again to radians, and that will be multiplying by math.pi divided by 180. This will be my t. And then in this cut I have this, and this will be parallel, and the distance will be t. Now I label this as south, and I put my compass in the edges. And then I'm going to create another profile. my profile will be for the back part of the stairs. I'm going to add here a profile that will be back, and this profile will have this shape. Doesn't matter the dimensions, because the profile will be set by variables, but the profile will have this shape, and the dimensions of this profile will be, the variables will be the angle, and I have to make another calculation. Let's set another variable that will be R. That variable will be run minus T. Go back to my profile. This will be then the width, that is the distance horizontally from this point to this point in this segment. My width will be R. Now I just have to select here in the north. I will use back, and here I have to select south, and let's see the result. The result now is this. Now you have your stair that is responsive in every dimension. If you change your rise at 4, it will respond. If you want to check if really 4, you can make an extrude here and put it here, rise, and as you can see, it is 4. The stairs have perfect calculations. Now you can add some more parts on your stair. If you go to your profile of your step, you can put a label here of floor. Okay, and then you can add another profile, that is your tread. That can be something like this. This will be tread. Floor, sorry. This will be floor. This will be floor. And in the sides, I select floor. And then I can make an extrude that for the east I put floor, thread. For the west I can put thread, and in the south also thread, and this will be the result. Now I have threads on my stair. About the slab thickness, this is the dimension 0.2. This is the dimension that I select here, that's why the calculation, slab T, if I fixed here to 0.3, my slab thickness now is 0.3, as you can see and you can see here down, my slab now is 0.3. Okay, this is the way to make stairs. I hope that will be useful for your future 3D experience. Bye.